Hi, thanks for joining me. In this video, we are looking at straight line graphs. In fact, it's a fair-sized topic, so this is going to be the first of two videos. We're going to have a look at the equations of some of the basic straight line graphs and also find out how we calculate their gradients. One of the first things we need to look at is how to draw some of the more basic straight line graphs, and we're going to start with vertical and horizontal lines. Let's first have a look at typical coordinate geometry, in other words, how we identify a particular point in a graph, and practice a couple of those. For instance, if I was to put a cross here on the graph, this will be found by counting along the x-axis first and then up the y-axis. So we would start 1, 2, 3, 4 and then count up 1, 2, 3. So the coordinates at this point are 4, 3. Similarly, if I put a cross, let's say here, this will be first of all along the x-axis -3, down the y-axis -2. So again, coordinates -3, -2. Okay, now we've had a look at how we do that. Let me just write down a set of coordinates. And I'm going to write 1, 2. Underneath there, let's put 2, 2. And then 3, 2, 4, 2. And then let's also have -1, 2, -2, 2. So a set of coordinates which all have one thing in common, and that is that the y coordinate is always 2. So let's plot these points. We have 1, 2. We also have 2, 2. We have 3, 2 and 4, 2. I also brought -1, 2 and -2, 2. Now, quite simply, we can show, if we use a ruler, that these points are in fact all on the straight line. And this line continues in both directions. So, it is a straight line where every coordinate has 2 in the y position. Therefore, we call this line y equals 2. It is a line that also crosses 2 here horizontally on the y-axis. So y equals 2. From this we can deduce that if we were going to draw the line of y equals 4, then it would be a straight line across the y equals 4 on the axis. Let's label that y equals 4. And similarly, if I were to draw a line down here, this crosses the y-axis at -2. It's another horizontal line, therefore this is y equals -2. And again, look at the coordinates. 4 -2, 2 -2, 0 -2, and so on. Every point on the line, the y coordinate is -2. Let's use the same logic then for a line that is vertical on the graph. So let me draw a line through the x equals 4 point. And in fact, if we look at the coordinates of the point where it crosses the axis, then it is 4, 0. Let's look at some other points on the same line. Here we have a point which is 4, 3. And further up, we have a point here at 4, 5. Once again, if we go into the minuses, the point here is 4, -2. So this time the y coordinates are changing, but the x remains the same. The x is 4, therefore this line has the formula x equals 4. All along the line, the value of x remains at 4. So to identify these lines quickly, let's have a look at the green line. It is horizontal. It crosses the y-axis at y equals 1, and that is exactly what this line is. It is y equals 1. The coordinates 1, 1, 2, 1, 3, 1, and so on. We then have a vertical line. A vertical line crosses the x-axis and it crosses it at -3. Therefore, this line is x equals minus 3. Again, pick some coordinates. We have minus 3, 4, minus 3, 2, minus 3, minus 1. The x coordinate is minus 3 all along its length. And the next line that we need to be able to identify quickly is this one. Let's have a look at some of the coordinates along its length. And if I start at the very top end here, we can see that it is at 5, 5. If I take a point, let's say here, here's the coordinate 2, 2. Right in the center at the origin, we have 0, 0. And if I go further down the line, maybe to this point here, we have minus 3, minus 3. Clearly there's a pattern growing here that in every case, the x and the y coordinates are exactly the same. Therefore, all along the line, x is equal to y. And this is the formula for this particular line. The y and the x coordinates are always the same, and because that is true of 0, 0, this line will always go through the origin. And the last of the 4 basic lines I want to have a look at is this one, which as you can see goes in completely the opposite direction to the one we just looked at. So again, let's have a look at some of the coordinates. If we look up at the top end here, the first point I've marked is minus 5, 5. Coming down the line here, we have minus 3, 3. Again, it goes through 0, 0, but out the other side, we have this point here, which is 2, minus 2. And going further down to say here, we have 4, minus 4. Now, if you look at the numbers of the coordinates, we can see that the digit is the same in each case, 5, 5, 3, 3, 2, 2, 4, 4. The difference is that where the x is minus, the y is positive, and also the opposite, where the x is positive, the y is minus. So in fact, whereas the last line was x equals y, this one is x equals minus y. It has the same value, but it is the negative. So if x is minus, y is positive. If x is positive, y is negative. So a line that runs straight down with same digits, but with negative and positive values, x equals minus y. It's also useful to be able to identify a straight line graph from an equation. All straight line graphs do have an equation, and they usually have x and y and a number. They can appear in a few different forms. You might get something like x plus 3y equals 4. You might find x equals minus y. You might have y equals minus 2x plus 4. In all these cases, although they may look slightly different and need rearranging, they all have x, y and numbers. There are no powers. The important thing is that if we see something that has an x squared or maybe an x cubed, it is no longer a straight line graph. It becomes a graph with some kind of curve. The next thing we need to consider on a straight line is something called its gradient. Now, quite simply, the gradient of a line tells us how steep it is. The higher the gradient, the steeper the slope. Let's go back to our original line here, which is the line x equals y. So again, we have points 5, 5, 4, 4, and so on. To find the gradient of a line, we pick 2 points. And it doesn't matter which points we choose, any which have nice straightforward numbers. So in this case, I'm going to pick the very top of the line, which is at 5, 5. And then let's pick a point down here at 2, 2. To find the gradient, what we need to do is draw 2 more lines. And they need to form a triangle between these 2 points here. So one going across and one going down. The next thing we do is we count how many spaces this line goes up and how many spaces this goes across. So, in other words, moving in the y direction, this is going from 2 up to 3, 4, 5. So this goes up 3. On the bottom line along the x-axis, this is also going from 2 up to 5. So this moves up 3 as well. To find the gradient, we take the distance it has travelled in the y-axis and we divide it by the distance it has travelled in the x-axis. So in this case, that would simply be 3 divided by 3. The gradient is 1. So x equals y has a gradient of 1. Let's look at another similar but different line. Now this line is also a straight line. It has a slope. It slopes up from left to right and it goes through the origin. We can see visually, however, that this line is steeper. We would expect it therefore to have a higher gradient. So we carry out the same exercise to make sure. Let's pick the point here at 4, 2 and let's pick the point at 2, 1. We draw two lines, we form the triangle again, so from here to here and from here to here. So don't forget we are counting the x movement and the y movement of the line here. So from here it has gone from 2 up to 4, therefore it is increased by 2. But this time on the x-axis it has only gone from 1 to 2, it has only travelled 1. So when we use y over x, we get 2 divided by 1. Therefore, the gradient of this line is 2. Let's look at a third one. So another straight line, but we can see again that the gradient is going to be smaller. It is not as steep a line. Again, let's pick a couple of points. Let's use easy ones. Here we have 4, 1. And I'm actually going to use the origin this time, 0, 0. So our triangle needs to come down the line here and across the x-axis. Now, if we count the numbers, on the y-axis we have gone from 0 to 1, therefore that is 1. On the x-axis we've gone from 0 to 4, so that is 4. Again, y over x this time is 1 divided by 4, a quarter. And that, in fact, is the gradient, a quarter, or 0.25. And finally, we need to look at the line that is sloping in the opposite direction. So from left to right, it is going downhill. This means that the gradient is going to be negative. It will have a minus value. We find it in exactly the same way. So let's have a look at a couple of points. Let's take 2 minus 1 here, and let's take 4 minus 2 here. And again, we perform the same action. We take two lines to make the triangle. Now, we have to bear in mind that when we are counting the y travel now, this line is actually going downhill. It has gone from -1 to -2. Therefore, it has gone down 1. Whereas in the x-axis, it is still going up from 2 to 4. Therefore, it has gone up 2. So y divided by x becomes -1 over 2. In other words, -0.5 or -0.5. So any line which slopes up from left to right has a positive gradient, and any line sloping downwards from left to right is negative. But the method that you find it is exactly the same in a line with a negative gradient. So there we've covered some simple equations and looked at gradients. We're going to use those as we take it a step further and start working with straight line graph equations and drawing graphs from their equations. If you found this useful, please do subscribe to Gary Duncan Maths. Hopefully I will see you again. Thank you.